Okay, this is the Fox MT-80AZ microprocessor trainer board for learning assembly language programming. In the last video, I showed you the basic idea of the board, how it allows you to load programs in and how to manipulate memory and run a program. But let's actually jump in and write a program, load it in, and see how it works. So this is a sheet from the original MT-80Z. Recall this board is later, and I don't have the user manual for this particular board. And one thing you'll notice over on the address column, their addresses start at 1800 hex, but in the newer board here, the address of RAM starts at 4000. So quite simple to make that change. So we'll just start at 4000 and load these opcodes and data in. So what we'll do is we're already here at 4000, so we're going to go drop into data, and I'm going to start loading in these opcodes. So the first opcode is 3E, so 3E. Next is, oh, that's funny. This was from the previous one, so I have to clear that out. Oh, from the previous time that I made the video. Okay, and so that's 4002 is 47, so we're going to fix that. And 4003 is 2F, and 4004 is D3. So start getting used to where these keys are. 1805 or 4005 on my board is FF. Next, 3D for 4006, so 3D, and 04 for 4007, 04, 18 for 4008, 18, and finally 4009 is FA. All right, now let's walk back through here. So we go FA, okay, that's correct, 18, 04, 3D, FF, D3, 2F, 47, 00, and 3E. Okay, great. So now we have this program loaded. It starts at address 4000. So what we want to do is tell the program counter to start at 4000. So we could have it start somewhere else, right? But I don't want to do that. So I'm going to make the program counter start at 4000. Okay. Whoops. 4000. There. Okay. And there's our program, the beginning, that first opcode there, 3E. Okay, so what does this do? So 3E is a load accumulator. The next address has 00, so it's loading the accumulator with 0. This code here loads the B register with the contents of the accumulator. This opcode complements the accumulator, so it whatever is a 0 becomes a 1, whatever is a 1 becomes a 0. And then we're going to do something tricky here. This is an output to a port. So this is the output of the accumulator to port FF. So what does FF mean? Well, over here in these on this area is a way to essentially program an output port to work with the processor to become port FF. So rather than go into all the details of that, this is port FF, these lights here. So when the board comes up initially, evidently port FF is latched with all ones, so every LED represents 1 bit. So what this program does is it outputs the accumulator to the port, decrements the accumulator, and for fun it increments the B register, which doesn't really have anything to do with what we're going to see. And then we're going to jump relative displacement back to our our loading of the or outputting the accumulator value to port FF. All right, so we'll take this piece of paper away and we'll run the program. So we're going to go PC, so we're going to start at 3000 and we're going to press go. Now watch these lights down here. They got a little dimmer, right? And this all went out. Why is that? Because the board or the Z80 processor is sitting there running this program, constantly outputting and latching data to this output port. So let's say I just stop this thing if I reset it. Okay, so this is just random. It randomly reset itself in time, and this happened to be what was last latched into that port. Okay, so we know that's running. Okay, so that is kind of it. I can start it again and run it some more. One thing that I can do is I can put a breakpoint in and let it run, and then we can watch this move along with the step button. So I'll do that in another video.